Hi, my name is Francisco Sanchez, and I am the president of HEDS Data Science. Welcome to the H-Stand Showdown. We finally get to debate which language is best for data science, R or Python. So join us as we discuss the pros and cons of it.
Hi everyone, thank you so much for taking time out of your Thursday night to come here and spend some time with us. I'm very honored to sponsor tonight's event and to have work with Houston Energy Data Science. It's always a good time when Francisco and his members are at campus, and so glad you guys are here. My name is Jeanette, and I'm the Community Marketing Lead for Flatiron School. We are an outcomes-focused boot camp, and we are launching Houston's first full-time data science program. And with that being said, I just want to, out of curiosity, how many of you are data scientists right now? Welcome. And how many of you are data analysts? Okay. And how many of you are looking to break into the data science field? Awesome. Well, you're in the right place because that's what Flatiron School is here for. We are starting our first data science 15-week immersive program on April 22nd, and we have an inaugural scholarship to celebrate that as well. And if you want to learn more about our program, and we also have software engineering, so if you want to learn more about it, we have our data science lead instructor, Rachel, in the back. And then we also have our data science technical coach, Rob. This is his first week, so he's very excited. And then we also have our software engineering lead instructor, Vidi, back there. She knows Python, so she'll be helpful as well. And then, as y'all know, I'm going to be around, and if you need your parking validated, or if you want to talk more about Flatiron School, I'm your girl. And with that, I'm going to let Francisco take over.
Hey everybody, my name is Brock Unruh, and I work for the company called Experis, and we're helping to sponsor the event tonight. And in short, Experis is a professional staffing group. We specialize specifically here out of the Houston market in IT staffing. And when Francisco approached us about the group that you guys are doing with data scientists and how you're trying to break into the energy industry, it sounded like a perfect opportunity because a lot of the large clients that we work with, I could be a name dropper, but we're in the energy capital of the world. Companies that can afford staffing services are typically large Fortune 500 companies, and so we're here as a resource for you. What we do to be successful is not so much hit the job boards, Career Builder and Dice and whatnot. We do that, of course, but we try to develop and leverage our organic networks. So going to events like this is very important to us. If you're interested in breaking into the industry, please come and talk to myself. Anna Medina in the back there is one of our senior recruiters for the Houston market. We'd love to visit with you, talk about your career goals, and try to help put a plan together to help you find your next position. So that's it. Thanks.
Good evening, everyone. My name is Tanya Davis, and I am with Microsoft Philanthropies. And whereas Brock and Anna are here to give you jobs, I am here to solicit volunteer support. So how many people in the room have heard of Doctors Without Borders? Okay, a handful. And so who can tell me what Doctors Without Borders, what they actually do? Anybody?
Travel around the world to provide health care to underserved nations.
Right, to underserved, exactly, thank you. So what TEALS represents, I am with Microsoft Philanthropies TEALS. TEALS stands for Technology, Education, and Literacy in Schools. And what we do essentially is Doctors Without Borders for software engineers and software professionals. So we seek out computer scientists, software folks who are interested in giving back in a philanthropic way to help underserved, and by underserved I mean high school classrooms. You may not know, but only 35% of high schools across the country are able to offer computer science as a field of study or a content area, and we believe that is insufficient. We believe that computer science should be offered in high schools in similar fashion to English, math, science, and social studies. And certainly the same as a foreign language, exactly. So what we do is we help to augment the talent, and we set our program up. It's basically like a professional development model for teachers. It's what we call job-embedded professional development, because the volunteers come in throughout the school year and assist the teacher in teaching computer science content to high school students. So she or he is learning how to teach. They know how to do the teacher stuff, but they might not know how to program or how to teach program. And so I am having several information sessions over the next couple of months. A couple down here in the downtown area, a few out in at the Microsoft Technology Center, which is in the Memorial area near the Energy Corridor. We have webinars. I will be around throughout our feisty discussion today, and I'm looking forward to it. And I am looking for Python programmers, so let me just throw that plug out there. But please see me, I'll be around, and I would love to answer more questions.
Thank you.
Thank you.
All right, thank you everyone for being here. Sorry. My name is Francisco. No, the other guy wasn't Francisco. So it's like the transition didn't go as well. But I'm the president of HEDS Data Science. As a tradition, we usually like to see whose first time is here. So raise your hand if this is your first time at a HEDS event. Oh man, cool. All right. So yes, we do offer all the rumors are true. We do offer beer and alcohol, so for free. So you're welcome to that. And I think the food is gone. So, but we do offer food in all our events. That's what we have been doing for the past 5 years. Been around for the past 5 years. We have one of our board members here, Scott Ferguson is here. So we are a nonprofit and a community nonprofit 501c6, and we do these events every month. So actually we've been doing these quite often now in the beginning of the year. So we usually have events, cool places like this, or cool places like Dave & Buster's at a brewery, or we've had events at a winery. So we try to sort of get you guys out of the office type of setting and get you like in a place where you guys are gonna have fun and get drunk and eat, so it's pretty cool. So welcome, thank you for being here. It's a Thursday night. So today we're gonna have the H-Stand Showdown. So what that is, this is like, I get this almost every single, I wouldn't say day, because I don't spend a lot of times with data folks nowadays, but like, they always ask, what is the best language for data science, R or Python, right? So I usually, and then I'm a SAS, I use SAS, so it's like, I don't know, right? But I know R, I use R for a little bit, and I've used Python for some web scraping. So, but I was like, well, this is a problem, a question that everybody has. So we wanted to have some two experts here to help us figure it out, right? At least answer some questions. And so the way it's going to work is we're going to have a panel here, and then they're going to start out with I'm going to ask one question, and then they'll try to answer it the best they can, and then I'm going to open it up for questions for you guys. Okay, so raise your hands if you have a question or you want to add something. You give out your phone number or whatever, doesn't matter. Just raise your hand, and we'll have somebody out there walking with a microphone to try to get as many questions. We'll try to limit it to 2 per session, and then we'll go on, and then we'll have a wide open Q&A, and then we'll close out and everything. So it's going to be a lot of fun. So at the end, you guys get to pick who the winner is, and we do have some prizes. So, Niraj and Trey, right? Trey. So if you guys get the most vote and you win, you get this awesome, outstanding achievement in the field of excellence. That awesome star right there in the middle. I know it says your name on it. I don't know who's going to win, but I will personally scratch that off and put your name on it, so don't worry about it. And then the first place will have a $100 Amazon gift card to go along with it. And for the second place, You also get everybody's a winner, right? So you get a certificate. Is a mediocre achievement excellence. And you don't get it's just like a happy face, not a star or this one. So it's cool, awesome. So you'll still be a winner. And this comes with a $25 Amazon gift certificate. So you guys be rocking and rolling. Now, if you come in third place, I'll just give you a hug. Because there's no, I hope there's like a 99% chance you guys are gonna come in third place with a 1% error. So maybe not. Okay, well, without further ado, I'm gonna ask these guys to go ahead and state your name. Come on over, guys. Don't be shy. And then state your name. Where do you work, and a little bit about yourself, and then I think we'll get started. So Trey's gonna be here.
Okay. This side or this side? Here?
Right.
All right. My name is Trey Hatch, and I work as the lead data engineer for Innowatts here in Houston. We analyze smart meter data for the electric industry, and we do basically build a mathematical model of individual premises and then aggregate those up to portfolio for our customers, and then from those we sort of build a whole bunch of other products based on that load forecasting. And I am solidly in the Python camp. And I will say, I noticed that you asked for Python programmers, not R programmers.
And I'm Neeraj. I work at January Advisors. I'm a principal there. We're a consulting firm. We work with a lot of large nonprofits, medium-sized nonprofits, mostly in social services. We also work with governments like the city, the county, on projects like the census. We do a lot of data collection, data processing, data visualization type of projects, and more on the consulting side, but we do quite a bit of infrastructure as well, and a little bit of machine learning.
Awesome. Please take a seat, guys, or if you want to stand, you can stand.
I might stand.
Okay.
Might get
All right, cool.
Maybe, yeah.
So the first question is, I know there's a lot of folks here that are just starting their career in data science. Some of them haven't or whatnot, but what do you think is, try to make the case for if you're a beginner, which language is best, R or Python for a beginner, so.
Okay. So I believe for sure that Python is easy to learn, and I think what you're going to hear me say many times throughout this question and answer and the night is the advantage to Python to me is that there is an amazing ecosystem of packages, libraries, resources available to you to learn, to troubleshoot, to understand how these things work, to use tools that are abstractions of difficult concepts. There's so much available that you can get so much done in a very short amount of time and with a very small amount of effort in Python. And for a beginner, there's tons and tons of information out there for how to learn Python. I mean, schools like this, YouTube videos, limitless number of blogs, Medium articles, all kinds of stuff that's available for the Python community. So.
Awesome, thank you.
So your question, just to clarify, you're asking for data science,
Yes.
What's easier to use for beginners?
Beginners, yes.
Yeah. So I think for data science, R is a clear winner for beginners. It's native to R. So, I mean, when you jump into R, you're immediately able to work with data frames and the different types of structures. You have a lot of tools for working with and processing data right there at your fingertips. You don't need to load a library. You don't need to worry about, how you're going to learn a new language and a new framework at the same time. You can just start messing with data, and you can add in libraries. Obviously, both languages have large ecosystems for working with data. And so you can load in libraries as you need them for different projects that you're working on. So I think that for that purpose, R is really good. I also really like that R has a lot of really good built-in documentation. Again, that's focused on functions for working with data and has little examples of working with data. And unlike the Python docs, I think R's docs have little examples of processing a data set in the help sections, and it has a set of built-in data sets as well. So I think that for beginners, you just jump into R and you start working on projects right away. I think that that makes it a favorite for beginners.
Awesome.
For data science. For other things, Python could. I mean, we teach Python to kids and stuff, so I think Python's good for that. But for data science, R is better to get started.
Okay, cool. Okay, do I have any questions from the audience?
Yeah,
Raise your
I
hands.
just wanted to
Sure.
clarify, you've both used both R and Python?
Mhm.
You both have? Okay.
Yeah.
Mhm.
And,
Yes.
when you started with Python, for example, what was the first step that you took? Did you just download it? Did you have a specific data set you were using? Was it more column-based data or cube data? What did you choose?
So the first, I'm trying to think the first Python installation, I probably downloaded Anaconda and installed it, and I had a very specific project in mind that I wanted to do. It was column data, and I'm trying to think, it was column data. It was something analyzing trades data, and yeah, I just got started with installing packages. I had programming experience before. I used Python. I had done Ruby programming, and then many years before that, JavaScript and ASP, .NET, and some SQL programming. But I now, just to answer your other question, I now work at a place that about half of our coders use R and half of our coders use Python. So I interact with both languages on a daily basis. Most of my work is in Python, and quite a bit of it is taking R models and porting them to Python for production.
Comparing the
Yeah.
results.
Yep.
You want to talk about that?
Yeah, so I'm so glad you brought that up about your first project. So that's another point I'd like to make, is I've seen a lot of people's Python installations just blow up in their face and stop working. I've seen people struggle with like trying to get their Python environment working, using Anaconda, and then getting stuck trying to figure out how to uninstall Anaconda and get all that stuff. And I haven't seen that ever happen with R in RStudio. It's really easy to get started on any operating system. So that's another point for beginners, I think. So my first project, let's see, I used Python before I used R. My background, I had done SQL, some database administration, and then I learned Perl, and I worked in Perl a little bit. And then I learned R because in a lab I was working in, people would use like point and click interfaces for statistics, and it was just so frustrating. And then there was this one student who came in, who we all made fun of. We were all nerds, but we called him a nerd because he was using R. And I'm like, haha, look at that nerd. And then I was like, one day, after everybody left, I was like, hey, can you teach me that? And I never looked back. I really thought it was fantastic that I can make reproducible research and stuff like that. And this was before Pandas had come around. And I was using Python at the time for making pipelines, for connecting different applications, moving data between them and stuff like that. And I think for data engineering, there's no comparison. Python is better. I'll give it that. But I don't think that's a part of the topic or one of your questions. Right? So,
Hold on, I'd like to disagree about that.
Go for it.
Yeah, I'd like to disagree about this last point. Because I think if you were talking about prototyping a data science model or exploring a problem, R I think is very improvisational, and it seems to be very easy to get something up and running quickly. But that if you're then talking about how do I do that every day, how do I go back and fix this if I want to dig into the code, how do I log messages out of this, how do I take what I have actually produced and was interesting results and then repeat that every day. That's something that Python absolutely does very well right out of the box. So you're logging your data structures, everything about it is built to make these types of things repeatable. Which I think is somewhat more troublesome than R.
Does anybody else have another question? Anybody here? Do you want some more beer? Anybody want some more beer? There you go. Yes.
Since both of you use Python and R, can you think of an application in which you would absolutely not use one or the other?
Oh yeah,
That would make it like this is why Python is better, or this is why R is better?
Sure. Oh, yeah. Yes, absolutely. I can think of a lot of applications, to Trey's point, for which I would not want to use R beyond a certain point.
But you're representing R.
I know. I'm going to come back there. I'm going to come back there. This is my strategy. I'm going to go a little bit over here, and then I'm going to go like zig and zag. Let me try it out and see. So with Python, I think it's good for the putting things into production, data engineering type stuff. I think that again, for beginners, like a lot of beginners aren't going to be doing that type of stuff. What a lot of beginners want to see, and also a lot of stakeholders for projects that you'll be working on in a job want to see, is they want to look at stuff. They want to see visualization. They want to see data. They want to be able to look at it and understand it. They want to see the pretty pictures, right? They want to see like the flashy stuff. They want to see things that look pretty. They want to see things that they can take to their boss and be like, look at what my team made, and something that they can really be proud of.
So you run it in R and then put it into Tableau and you're done.
Right. Well, Tableau is only so pretty, I would argue. Although, unless you've got Ivan on your team, that changes the picture considerably. He's pretty good at it. But I would say that in R, you can make really pretty pictures really quickly. I would say I've really been disappointed with data visualization in Python and Pandas. And so if I had anything that I needed to represent something to a client or stakeholder, graphic, which is almost on every project, they need to see something, I use R for that. And then I can go into Shiny and build like a little web application, and it's really quick to do that, to take the graphics and make them more interactive and exploratory. So I think that for that type of thing, I would never use Python. And if I was going to use something that was a little bit more a step up from R, I would go to something in JavaScript from R. I wouldn't go to Python for that.
Yeah, so I think absolutely the same kind of thing. There are some things that I would not do in Python. I'm borrowing your strategy for a minute there. But for example, we have a process that we're looking at right now in our data pipeline that just performs faster in R. It happens to be this particular calculation works better there. So that's absolutely a place. That type of calculation and that particular type of process I would not do in Python. And if you're prototyping something, if you're trying to get something done quickly, if you're trying to visualize something that's sort of a one-page single static thing where you're going through an exploration of data, I think that's quickly done in R. I think that it's also now very quickly done in Python through Jupyter Notebooks, through many of the visualization libraries that are there. I think I disagree with the last point about if you wanted to take something and move it into a interactive application or sort of an interactive set of data, charts, graphs. The tools that are available now in Python that are pure Python tools, even the web servers all the way up through the actual visualization and charting, what's available now is amazing. We use Superset, which is an Apache software that's specifically for visualization, and it's an amazing front end to data sets. It's pure Python. It's and what you can do if you want to give someone something that they can sort of click through, that they can explore their data, that they can do more than just look at a picture. Python provides a lot of tools to be able to do that. I think I also my personal comment about the aesthetics of one versus the other. I think when you produce visuals in R, just because the body of work that's been done that way, they tend to look very academic. When you do, visuals in Python, you end up having things like Seaborn, you have Plotly, you have a number of tools that are available that have a very different aesthetic and look. And I prefer that look rather than sort of the academic look of R. So.
Cool. Any other questions? Any other questions? We got to hear from the back one of these days. Okay. So. There you go. Over there. Okay, hold on a second. We got to hear you.
Sorry, less of a question, more of a comment.
Okay.
R has been thought to be academic, but I think the past, say, 3 years since I've been on it, it has moved beyond academia, I think, to more commercial and more fun, I would say. So if you're a beginner who likes fun, I think, yeah, go for R.
I didn't pay him to say that, but I might share my Amazon
First,
card.
I want to say this is all in good spirits. I think both languages are great, and I say this with just making a joke. When I encounter R, I say it's a language created by grad students, maintained by grad students, used by grad students. That's the way I feel when I work in it. It's I feel like the package management, the way that you interact with the sort of nuts and bolts of language is somewhat disorganized, but I don't feel like it's getting more professional. But that's
Okay, so that's the question though.
Yeah.
As far as accuracy goes, academia goes out the window because all things are not held equal, right? So if R is purely accurate statistics, should we be using that, or does Python provide more flexibility?
I mean, you're making the same calculation. So I mean, we've actually done comparisons of
But
models.
does it allow more model flexibility than R does?
Well, Andrew, you want to? I can take it. Yeah.
Does Python offer more flexibility or not?
I mean,
So
Modeling.
I'll frame your question in the form of something that like I do have an answer to, if you don't mind. So in terms of flexibility in models, if you're asking like which one has more statistical models implemented, it would definitely be R. And the reason for that is the same point. It's more academic. So a lot of statistical research journals, when the professors and the research teams publish a new statistical method, they publish an R package with it, right? Yeah. And so you've got lots and lots of libraries. Also, to Trey's point, a lot of those libraries are shit. Like, they're really bad because they're written by academics. And I know Paul's seen my code when I was still like very much an academic, and like it was not very good. You didn't want to use it more than once, really. So that's how academics are. But more statistical methods are implemented in R. But in terms of like for a given model, if it's implemented in R, implemented in Python, it should be the same. You should have the same arguments. A lot of these models are defined as math, and so all of the parameters should be the same between the both. If that answers your question.
Yeah. And I would add, I think you're saying that there's when a new statistical method comes out, it often comes out first in R, then usually is quickly ported to other languages. I don't think there's a big lag now between the two packages. Like, it's oftentimes come out almost exactly at the same time. But when I go in and look at those things, I get frustrated by like lack of functions, and the organization looks strange, and it's difficult to like read through things and understand what's going on.
So, a lot of people's introduction to these type of languages usually comes in the database portion of it, right? People don't want to see their data in a nice visual graphic, and they see all these cool database options in R and Python. So a lot of folks come from either some kind of BI tool like Tableau or TIBCO, and then they transfer over to Python or R. So I think you guys touched on it a little bit earlier, but can you give me more an insightful of a view of which of the languages is better, Python or R for database?
So I see your strategy now. You don't let me go first. I see. That's
Point,
okay.
counterpoint.
All right, so you're a counterpuncher, right? Let's see. Okay, so for me, again, I made the point pretty strongly earlier that I think R is way better for data visualization for a number of reasons. I think that ggplot has created a very nice extensible ecosystem for graphics. That's graphics first, right? It comes from the theory. GG is short for grammar of graphics. It comes from a theory that's about making it such that you're not locked into a particular chart type, right? Rather, you're thinking about data as it maps over to marks on the page or the screen, and you're thinking about the mapping functions for data. You're thinking about what data is represented as what aesthetic elements, like a color or a position or a shape or a size. And I think that allows for a lot more creativity and a lot more beauty in some of the work. which is easy to do. There's a lot of functions for changing the colors and scaling them, doing really interesting things with them, and changing fonts. There's a lot of stuff built in. So it starts with, like, out of the box, you write a really short function and it gives you a pretty good looking graphic. And then you add a couple functions into there, and they're interchangeable in a nice way, and all of a sudden you have a very custom looking graphic. So I like that kind of runway toward, from like something really quick that looks pretty good that you could show somebody and not be embarrassed, to like something that's like, wow, how'd you make this? We're gonna publish this in the next whatever newsletter. So I think that's pretty cool. Then you take that, plus you add this idea of R Markdown, which is I can take my code and I can have my graphics in there, and then I can have Markdown, which is like a text annotation type of thing. So I can turn some basic text into like a web page type format, and I can have that woven together with the output of my code and have a nice report, a PDF that I can send somebody, or an HTML page that I can send somebody. Some of those graphics could even be interactive in the HTMLs. And then you talk about taking that same code and then repackaging it a little bit and having this shiny application type of idea where you could have sliders and some type of interactive dashboard. So I think, again, that evolution of going from a very short function where you have a nice looking graph and not having to fight the syntax too much to get something really good looking and more interactive and respond to feedback from the people you're showing it to. I think that just makes R much more pleasant to use for these types of things, because in my experience, I'm in a lot of these situations where I'm showing something to somebody and having to go back and make changes. And I've gotten really frustrated with some of the things, especially using matplotlib syntax, like trying to do the thing that somebody asked me to do that I can see on paper, I can draw it out, I can kind of understand how I want to do it, but I'm really fighting the syntax and the library to get it done in Python. I haven't really had that experience in R.
Yeah, I think that those similar tools are, that may have made their way into the Python ecosystem as well. I think that when you first started, when R first introduced those things, they're amazing and can get those things done very quickly. Now we have libraries like Seaborn in Python. You've got Plotly, which we said earlier, that it does something very similar to Shiny, where you can very quickly make a interactive application. I think both languages have a number of tools that are readily available to quickly prototype a sort of story about the data. I mean, that's kind of become the motto of the data scientist is, how am I going to tell the story of this data? Like, I'm going to write sort of a report. I'm going to talk about what process I went through in my Markdown. Then I'm going to show you my bits of code. Then I'm going to show you what the visualization of that data looks like, and then I'm going to give that over to someone who's going to help either make a decision about it, or then maybe turn that into some sort of production code. And I think that actually works really well for us. We've got guys in our data science team who give us code in Jupyter notebooks all the time, and it's an awesome way to work, because then you understand their thought process as you go through it. And you can very easily see sort of what they were intending, and then what they want to do when this thing is running in a continuous basis. And so I think both languages are excellent for that type of thing.
Thank you. So do I have any questions from the crowd over there? Oh, we got two over there. Okay.
So
either one.
So in other language, whether it's R or Python, it's a base code language that you're using, but to enable you to do the things you're saying you're doing, I mentioned, I hear the word tools or upgrades and stuff like that. Are those things you're purchasing separately and bolting on those into your code, or how are you doing this? Is this open source stuff that you can use, or how are you beefing up your technology?
Sure, almost everything that we use is open source. There's so much available that's free or open source. Like I was mentioning earlier, Apache Superset, that's an open source software maintained by the Apache Software Foundation. Plotly is also open source. Seaborn, also open source. Jupyter, also open source. I mean, there's so much available that the community has contributed. I think I was reading earlier, there's something like 180,000 libraries now available for Python that contribute, all kinds of upgrades, bolt-ons, whatever you want to call it, to your sort of core tool set. And in addition to the very, extensive set of functions and data structures and stuff that are available in just the core Python installation.
Yeah, I can't think of anything you can buy for R. Like I think everything's free. You can buy services that help you run your R code, for example, like somebody who will let you borrow their environment to run your R code, and they make it really easy to deploy and help with there. But I don't think you can buy R libraries really. It's all open source and free, but that's kind of the beauty of it is, I mean, I've written an R library. I've written a couple R libraries. One was useful, the other one was not. But the idea of it is, you can contribute the same as everybody else. You have a bunch of things that you're doing that are common workflows, and you're like, maybe other people would want to use it, but I definitely want to use it again. You turn that into a library. Often you're your first user of a library, or you and your team are, and that gets published, and that's really kind of the nice thing about it. Everybody who's got cool ideas just shares those ideas back into the ecosystem. And that's true of both Python and R. Both are very healthy, very robust open source ecosystems.
Yeah, the open source community is an amazing thing.
Yeah.
I truly have not appreciated its power until really getting into working with the tools and what people have given away for free. It's amazing. It's a lot of powerful tools out there.
Yeah, definitely. Agreed.
Agreeing is not good TV. I'm trying to get more subscribers to our channel.
Yeah, give us some more beer.
That's right over there.
You want us to get animated?
Yeah,
All right.
Bring that beer over
I'll stand
here.
up. I'll stand up.
As far as third-party integration, to mind it comes that I think Maya 3D uses Python and ArcGIS uses Python and TIBCO uses both, but what do you think is winning in that space as far as third-party integration?
I definitely think Python's winning in that space. I mean, it's infinitely more easy to me to produce something that is reusable in a new environment with Python. We try to approach our code strategy of, like, if we're going to produce something, it's going to be a piece of code that we can run as a module that we can import somewhere else, but also something that we can run from the command line. And so it's very easy to take the same exact set of code and produce, your default arguments, your default, command line arguments, all of your help strings, so that if you run the, command line without the required arguments, you get information back from your software. It makes it a much easier piece of software to use. In addition, to me, the logging out of Python is tremendously easier to deal with and use than it is in R. And then I think, like you said, there's a lot of places that are, starting to pick up R just as a scripting language for their particular, C application or C++ application or whatever their desktop application is. They're using Python as a scripting extension to that, just because of the availability of all these tools and also just the sort of ease of use in that context.
Yeah, I think now is a good time to talk about an important distinction, which is that Python is a general purpose programming language, and it's got a great ecosystem. When we talk about ecosystem, we're not talking about just data science ecosystem. We're talking about the tools for logging, the tools for like creating excellent code and stuff that will last and run forever. Like I've used both, right? And I would still use Python for an application. I've used R for applications before, and it was a terrible mistake. It's a mistake that I'm not paying the price for, but a lot of my friends are, or people I've worked with before are. But Python, the Python applications I've made, most of them are like still running, and I haven't thought about them in years, right? They just run. But that's general purpose programming. So I think if what we're talking about here is data science work, the tasks of a data scientist that break down into a range of things, some of which I think people would consider the application building and delivery of stuff into production, but the rest of which, the majority of which is not that. The majority of which is really just working with data, like face-to-face with the data, face-to-face, and then something shows up and then you take it to show somebody and they make a decision about it, and that feedback loop, if we're talking about that, then I think R wins, right? That's what R is built for. That's what R is. Like when you open R, that's what you have. When you open Python, you have a general purpose programming language. And you can get yourself into, like, I liken it to like a fishbowl, right? Like if you're a fish and you just like go jump into a fishbowl, that's like what I feel like when I'm in Python and I go into working in data science, right? Like I'm in this huge ocean of all the cool stuff I can do with Python, and then I just like take myself and drop myself into a fishbowl. When I'm in R, it's like I can't do some of the things I can do in Python, but I'm in like an aquarium, you know what I mean? Like a really big one, you know, like the Atlanta one, you know, with the tunnels and everything. So I feel pretty good, right? I could be like a whale shark in there and be like, yeah, this is my aquarium. So I took that a little too far, but you know, I hopefully get the idea. It's like Python, it's like you kind of constrain yourself in Python to do data science stuff. Play by some rules, you can do data science stuff. In R, it's like they just keep adding stuff from other languages because they're like, hey, we actually want that over there too, so let's get that and that and that, and they kind of add it in. And sometimes it works, sometimes it doesn't, and you get frustrated with it, but it's kind of like people keep building additions to the aquarium, right? And you're just like, oh, this is over here too, and I'm gonna do that too. And it's less of like constraining yourself to do data science from a general purpose programming language, and more like, I think, just being in a wide open space that's made for data science. And then, as far as the third-party integration stuff goes, I don't think that's the role of a data scientist. The people who make those applications are application developers. Like, they are not data scientists. And there's a point at which you hand off a project to an application developer. And sometimes there's this idea that's growing, that data science as a role is growing. So I see job descriptions of people who you expect them to know like 5 languages and have 10 years of experience in things that haven't even existed for like 3 years. Yeah, like, you know, you have like, you see ridiculous job applications called data scientist, and they've got a, you know, $170,000 salary on there. It's like, great if you can find that person, right? Like, that doesn't exist, and I think that's gonna change soon. I think that's gonna have to change soon, and we're gonna have to start thinking more realistically about what the role is. And this idea of data scientist, I don't think makes sense. Maybe that's subject for another panel.
I already bought the shirt.
Yeah, I'm sorry. Data science is okay, actually.
Oh.
Really? So like little preview of that panel. Data science is okay. Data scientist doesn't make any damn sense. It's like, I do science, I believe in science. That's fine, that makes sense, right? I do science. But I'm a scientist. It's like, what? What does that mean? Like, a scientist, what do you do? It's like, when you say I am a what, you're talking about, it's a shorthand for what you do. And I don't think being a scientist makes sense. Science as a field makes sense. And data science as a field makes sense. But anyway, that wasn't your question, so I'm gonna.
I want to respond to that one, though. I think, you know, as I've seen the role of data scientists in our organization, one of the things that I think ends up being challenging to them, specifically working with R, is that they are doing this exploration, this sort of free form, you know, like improvisational, like look at the data. But when they go to then try to do something with that tomorrow or the next day or whatever, then the processes that they've gone through to get to where they are, the first visualization or the first sort of exploration they had, don't work when they try to do them every day. And I think that role of data scientist is going to grow as we put more data science-y type stuff into products, right? There's not enough people with these math and programming skills out there, so there are companies that are building these things into applications for use by people in different industries. And so that the data scientist has to be able to perform logging. They have to be able to, you know, write their code so that someone else can use it, because if not, they're going to end up supporting that application every day, and they're going to be running the same thing, the same prediction that they've run yesterday. They're going to run it tomorrow and the next day and the next day and the next day, and it's something that's just not sustainable. And then it doesn't allow them to get to the next fun thing, which is building a new model, exploring a new data set, finding out something new, improving something they did before. Like, all of these things that seem like you're saying, I think Python being a general purpose language, all these things that seem like they're, like, I don't know, unnecessary is the word, but like that they're above and beyond what you need to just perform the base data science work. Those things are there for a reason, and you can take advantage of them, and you should take advantage of them, and you should learn as much about that tool set as you can, so that you can produce those results on a daily basis and then hand it off to someone else who can support it, who can troubleshoot it, who can help implement that thing for a new client or a new user, or they can put it in a new application. So I think that those tools are becoming more and more relevant to a data scientist.
Cool. Thank you. Another question is, a lot of folks do Kaggle competitions, right? And they run machine learning algorithms, and then they get to the real world and find out that, oh darn, data is not all structured and all nice and clean. And that's a lot of problems a lot of folks face in the real world. So when we talk about data wrangling, data munging, making data machine readable, so we can run all these cool algorithms and put them in these great database packages. What do you think is better, Python or R for data munging?
So whenever I look at R code, I struggle to find where is the function. I don't know where a function starts, and it's confusing. And I think when you do data munging and you are going to wrangle data, you're building this library of functions. You're building this library of things that you're just going to repeat over and over and over again. You're going to look at this data and does it have zeros? Does it have nulls? Does it, is the values out of a range that I'm not expecting? Did somebody put the columns in the right order? Did they put the date where it should be an integer or a string or whatever? Those things are just functions that are repeatable, and whenever I look at those in an R program, they're very difficult to see where they are and see how you call them, and it's just the structure is weird. So I think when you're doing these things, if you're going to repeat this stuff over and over again, Python gives you this very nice syntax, and then also gives you like a built-in style guide. The Python, there's the PEP8 concept, which is a whole set of style choices for how you put your Python code together, so that when you look, if your code is PEP8 compliant, and then you open up someone else's code, it looks almost exactly the same. The functions are written the same way, the line spacing is done the same way. It looks very readable, and it makes it very easy to orient yourself within this program or this script that's running. So I think it's to me no contest in that particular arena. So.
I've got a cheap shot lined up here. I think that's the developers who you have on your team. Like, I think that it's just the case that if people don't use functions, then their code's going to be unreadable. And both R and Python have a blend of object-oriented and functional approaches available to you. And so you can make beautiful code in R, and you can make really ugly code in Python. I've seen a lot. I've written a lot.
For sure.
So you can do, and style guides are style guides. I mean, PEP8 is great, and it's a very universal thing. But there are style guides for R too. You could just Google R style guide, and Google has an R style guide. So style guides are style guides. And discipline of and kind of enforcing that people write functional code is going to be common to both. So I have to negate all your points, because I think that it's more about developer and users. And if you're reading code from people who are not using functions, you got to be like, hey, you got to use functions. I think I've had to coach a couple people back there on the same thing. So it's one of those things where it's more on the developer. In terms of things that I do believe are different, there's, Python is pretty nice in terms of things like list comprehensions and being able to do a lot of work in like a condensed way, and that's an advantage of Python. But R has this idea of pipes, so if you write functional code, you can actually then take your data set and pipe it through a set of steps, a series of steps. And you don't even have to have any arguments in those steps. You just have those steps listed out as plain English almost. And you're piping the data through that, and it creates this pipeline your data flows through and comes out in the way you expect, and you can swap pieces of that pipeline in and out. I miss that when I'm coding in Python. I think that's a really cool feature. And they borrowed that from another language. They borrowed that from the shell, actually, from Bash, from Linux, being able to pipe the output of one function as the input to another. And I think that's really nice for data wrangling and for experimenting with different functions and working with data. And then I also think that in terms of working with munging. I actually don't like doing it in either language very much for very long. So I think that one thing is, I wanted to make this point. I just thought of it while you were handing the mic back on the last question, so I'm just use it now. You know, I think that Python is like, it's like a long haul like cruiser. Like, you can put something in there and it's going to get where it's going. It's just going to be there. It's predictable. It's reliable. It can carry a bunch of stuff. It can work with lots of data. You can push lots through it. R might struggle if you feed it too much data. Ours may not make it all the way to Austin, but it's like a Tesla, you know? Like, it's going to get 0 to 60, 0 to 100 really fast. It's going to feel great when you get there, but you stop halfway to Austin and you're like, I gotta go plug this thing in, and I gotta, you know, like, there's that. So that's a real thing. But I would argue that a lot of data science in a lot of teams is more of the city driving. And I think that there's this idea of, it's like, you know, you're going back and forth lots and lots of times to like the same thing. And you're often changing it. You're not really putting it into the log hauler and being like, all right, I'll see you when you get there. You're like constantly going back to it. And when it comes to data wrangling, I think it's also that. It's also a lot of like trying to solve a puzzle. And you're going back and forth to the code really quickly. You're not putting it into production. You may use logging to solve that problem, but you're not even getting to that point. You're just right there with the code and it's not working the way you want. And I think R is nicer for that. Even better than, even with Jupyter, I think R is still better. But in terms of getting like something, from there into an application, to your last point, because I can't let it go. To your last point is, you have this idea of a data scientist who's got to, you know statistics, know data, know the domain, and know how to make applications. I really think that that's something we have to start to get away from. They need to understand how applications are built. They need to write functional code because it makes it easier for other people to read it. But they don't need to build applications, and I think that
I don't think I was. I understand what you're saying, and that wasn't really what I was trying to say. I think you do have to understand how applications are built, right? That's more of my point. Is that you have to understand what are the principles, but to understand really how applications are built and to understand the principles of it, you have to do some practicing of that, right?
Yeah.
You have to practice those skills. It's just like any craftsmanship, right?
Yeah.
You've got to do this over and over again so that you can do it. And I feel like I've got to defend my team. They do write good code.
Good.
Like,
Glad you did that.
No.
I expected you to do that.
Yeah, no, I don't want to say that they don't write functions. I was saying that when I open it up, it's difficult for me to see where they are. Like it just doesn't pop out the way it does when I look at Python code. Like when I open it up, I expect to see this Pepe formatting.
Yeah.
Like I expect to see the indentations in the right place, and it's like it's very easy to scan it almost just by the shape of it that it makes in the IDE, right? Like, here's my header block, here's my next set of functions, here's my sort of tail where all my end arguments and my command line stuff is, and it's nice to be able to see it that way.
Mm-hmm.
So.
Yeah, fair.
Okay, Francisco, I have
Yes,
one last
go ahead.
question. It's a two-part question. So, my brother's been a programmer for 20 years. I asked him which one I should use, R or Python. He said neither, they're shit, they're open source. Second part of the question, I work for a small partnership. We have less than 500 lines of data each day. We have unlimited cash flow. Which one would you use, or would you go out and buy a better product that actually costs money that's not open source?
500 lines of what type of data?
That's confidential.
Okay.
It's transactional data.
I mean, it depends on. I mean, there's tons of tools that are available.
It's confidential information, literally. It's,
Okay.
socials.
Depending on what you're trying to do with it. I mean, if there's a very specific use case, there's probably a product out there that does just that. Like if you want to transform this data into that, it's absolutely something you could probably find a tool for that's a paid tool. The reason that we do programming at our shop is we are building a product. We are building a product that someone else is going to use on their data. Right? We're not trying to just perform this particular function for our data set every day. We're trying to perform this particular set of functions on a number of different types of data sets every day. So it's I think if you were just performing the same thing over and over again, I would look for software as a service or as as something that you're able to purchase as a tool. There's I think there's a learning curve on any programming language. So if you have a specific set of things you want to do, the number of things that can go wrong when that stuff comes in the door are greater than you might think. So when you start to try to tackle the problems of how do I get this data into the format that I expect, how do I make sure there's no errors in it, like you end up going down a bunch of rabbit holes, and if someone's already done that for you, why not take advantage of that? Cool.
I think if you had unlimited cash flow, then you should hire us. We'll take care of it for you. And I mean that in all seriousness. I mean, like, if you need to build out in-house skills, then learn one of these open source tools. Don't get locked into a particular vendor. So you're waiting, at the end of their development pipeline for features. Like, learn one of these tools if you want in-house skills. If you want software as a service, you're still going to be on the end of kind of a development platform, a development pipeline.
Let me correct this. This is a small partnership. We literally create any business we need so that we don't outsource. Anytime we want something, we're like, oh, well, we want to advertise on the radio. Okay, well, let's create a company that advertises on the radio. We don't outsource.
Yeah, so then if you don't want to outsource, you can still hire us. We'll help you build the business, and we'll help you outline the processes. No, but I mean, anyway, I think if you are building a business, then you should get open source software people, because they'll be more flexible, adaptable, and things like that.
And your licensing is much better.
Yeah.
Okay.
Is there another question somewhere?
So I hear a lot of back and forth about the ecosystem and the active programming in both languages, and I have a clear bias towards Python because I'm more, it came from the Unix tradition of scripting languages and all these things. Like the programming niceties and tools they're there, right? But the first time I wrote Python and the first time I wrote R would have been about the same time, would have been about 2007, 2008. And in Python, I mean, there's been more web tools, there's more stuff, there's ever-growing amount of libraries, but the core was already there, right? PEP was in there, early 2000s, late 90s, whatever. It's all been there. And what I've seen happen is that I think about the first time I wrote R, how clunky it was. I think the tools that just didn't exist. And I think about sort of the ecosystem trajectory. And I don't know, my personal bias is still very clear that Python has these rich advantages you're talking about, from being able to operationalize things once you're done with it, to all the growth in tools and these things. But my question is for both of you actually about the R ecosystem and the trajectory it's on. Because again, I see that Python has had more stuff, but it was never a question that it was easy to work with and had these niceties, the type of people that wrote in it, abstracted their code beautifully, etc. From both of you, I'm curious about the R ecosystem and your thoughts about it and its various trajectories and what you've seen changing in the last 5 years and what you might see in the next 5 years type thing.
Yeah, I think, Hadley Wickham's certainly been a catalyst for the R ecosystem. He came up with a philosophy, a design philosophy, which is he would study, and again, this came from his academic background, he would study how things were done in other languages. And he would really try to understand not just how they were implemented in that language, not just the syntax, but really he would try to understand the pattern that was being applied in that language, and he would bring it into R. And I think that all of a sudden really, the kind of transformation that Ivan was talking about, where it broke out of academia and started getting used a lot more places, I think that was part of it. I think the trajectory continues. I think there's, with the IDE that they have now in RStudio and the whole ecosystem of being able to deploy Shiny apps, and now you're using it for making some basic applications. I think the trajectory continues, and I think that people in R are starting to be like, why can't we do the application stuff? And they're trying to figure out how to add some of that stuff. And there's been starts and stops, but I think that's an interesting thing to observe. And Shiny is a good example of that. But in terms of what I've seen though, is I think that a lot of the focus on the user experience for a data person has actually started to be ported over to Python, right? So I think when it comes to machine learning libraries, R is always they got things with the user experience for a data person. Python's catching up. They've caught up, but they're constantly playing catch up on a lot of these features and patterns and things like that. And so I think in that sense, for a lot of the day-to-day work that a data person would do, R is in the lead.
Yeah, I think also the ecosystem of Python continues to be supported by huge organizations, right? You've got large companies contributing to the open source development of not just Python, but the Python tools. And I don't see that in R. It seems to be still very academically supported. I don't see the initiatives coming from large organizations contributing to these apps, because I think that they see that, look, if we're going to do application development, we're going to do sort of this nimble approach to application development where we can use something like Flask App Builder or Plotly or Dash or whatever to get a visualization up very quickly. A ton of that work has already been done in Python, so let's continue to contribute to these Python projects. And I think that you'll see more and more of those companies contribute to those projects, and those projects will continue to accelerate faster and faster.
Thank you. Okay, we have about a few more minutes, 10 minutes, so I'm going to add 2 questions more, and then I have a special question for you guys. I hope I don't stump you. Andrew? Yeah.
Yeah,
We have
right
about
here.
10 minutes.
And my question's about location. Most data has a spatial component. Spatial data, although it can be wonderful, it also tends to have issues with autocorrelation, where the autocorrelation signal is so dominant that it's hard to tune into other signals that you might be interested in. And geospatial data also tends to have more complex data structures like SP and S4 data structures. As a lot of the fancier data science that's occurring at companies like Uber and Facebook and Google is being done on spatial data. So perhaps you guys could compare the capabilities of R and Python in handling spatial data.
I don't know that I mean, we don't necessarily deal with a lot of spatial data in our day-to-day processes. I do know that as we've gone through and looked at visualizations of how we would start to visualize these data sets if we had the spatial component to them, I've ended up back at tools like those developed by Facebook, Kepler, and then specifically we chose Superset as an internal tool because of its ability to visualize spatial data. I think that you treat, depending on what types of transformations or explorations you want to do with the spatial data, the libraries are there in both places. Like, if you want to do just a haversine distance to figure out what are my meters or what are my items within a particular range of distances from this point, those types of libraries exist in both places. I think if you're talking about more complex spatial things, I don't know that I can answer that. I'm not really familiar with what libraries might be out there. I know that when we look at spatial data, I just look at it as just another set of columns. It's something that I use another package or library or whatever to process that stuff to figure out what's sort of clumped together.
Yeah, I mean, I've seen quite a bit of spatial data. We do, about half of the projects we do at my company are maps, and we tend to process a lot of spatial data. We use R a lot more than I thought we were going to. I've been pushing our company internally to use PostGIS a lot more, because I think for the data munging, data wrangling question too, I think SQL is really underutilized in a lot of places. And it's really still the best for a lot of the things we try to force R and Python to do. I think any library in R or Python that can call out to SQL in like a natural interface, both of them have those, should be utilized more. So PostGIS would be really a good tool. But we do a lot more stuff in R than I thought we could. For example, you can take a polygon of like all of Harris County, which has all kinds of really weird corners and edges on the perimeter, and simplify the boundaries. In other words, it takes up a lot less space in file storage if you simplify the boundaries a little bit. And you won't notice it unless you zoom in way in. but it helps a lot in terms of the speed of any processing and things like that. So libraries that have functions like that, with that kind of sophistication of looking at intersections, looking at simplifying boundaries, things like that, merging polygons, all of that is available in R. I've been pretty impressed by it.
We got time for one more question, just a quick one and a quick response. Yes, sir.
Hypothetical here. Which language do you think is much easier to use to parse if you had a 2 gigabyte binary blob downloaded from the Hubble Space Telescope? It's not just raw visual data, it also has magnetic readings and stuff like that. Which one would be easier or faster to use?
What are you trying to parse out of it?
Okay, let's say spectrums of color, perhaps. Yeah. Fortunately, you also know the data structure of this binary blob. But which one would you recommend? It's easier to parse that binary blob.
Are you talking it's like an HDFS file or something like that? It's
No,
got some structure to it, or
purely binary.
Okay.
No, you only know the data structure in theory.
I mean, unless you were talking about doing something specifically with a package that had some sort of a C binary that went with it that allowed you to do frequency sort of manipulation or frequency exploration. I don't know that that's something I would do directly in Python. I mean, it's definitely the tools that you use on a daily basis for like data wrangling and data munging and visualization are really centered on column-based data and going through data frames and building functions that are there. If you're going to look at something like that, I don't know that I would use Python to do that. So,
Yeah, I think if I had to choose between the two, frankly, I would try to use Python and some of the tools for introspection into binary files and stuff like that are built in. But I really wouldn't use either one. I think what I would do is I'd use something, actually, I worked with a genomics data set, which was massive, lots of binary data. I couldn't get it to work in Python, I couldn't get it to work in R. I like spun up this massive, super expensive server on AWS and I couldn't get it to work on there, and I was like, oh my gosh. And then I started using the Unix command line tools for parsing like files, and I could run it on my laptop. It was like amazing how powerful those tools are. So if you're working with really large, complex data, but you know some basic rules of how you want to parse it, I really encourage you to check out those Unix tools.
yeah.
And then
awk and sed and
awk and sed, and
amazing.
like the ones for splitting lines and doing all this stuff, and it's just like each tool has like one job and it does it super fast because it's been around since like the
highly underrated.
70s. Yeah, and it's just still the best tool and the best implementation of it. So I would highly recommend doing that, and then put it into a file format that you can read and play with in R or Python.
I mean, just to add on that, I find myself going to these tools more and more every day. Like I use awk and sed and every day, and more of my work ends up being in just scripting, Linux command, like shell commands, than it does in doing something in Python specifically.
This is an R versus Python. But that's cool, that's cool. It's the last question. So my question is a pretty dumb question. I usually have a lot of those, plenty of those. So just curiosity, where did the name Python and R come from? And please don't say the jungle and the alphabet.
Python, I have no idea, to be honest.
It's not a dumb question.
Yeah, no.
You want to answer?
No. Yeah, somebody else knows, please.
Now
Somebody else know.
Python came from Monty Python.
Oh, that's right. Yeah, the creator was a fan of Monty Python.
Oh,
that's right.
okay,
Yes.
cool.
Yeah, that's right.
And R does come from the alphabet because there was a proprietary proprietary programming language called S. And S was short for like statistics or statistical language. And they wanted to make a lot of the same tools in there, a lot of the same syntax open source. So they went from S to R.
Awesome. Okay. All right, guys. I think we're gonna conclude here. So now it's time. Wake those guys up in the back here. It's time for your civic duty here to go ahead and vote. So I don't know. To me, it was pretty close. We might have to do like a thumb wrestling to figure it out. But so please, if you love, just based on the discussion here that we had, even if you love R, Python, whatever, or SAS or SQL, just raise your hands if you think that the R argument won. 1, 2, 3, 4, 5. How many is that? 6, 7.
I think I lost.
8, 9. I don't. It looks pretty. I can't. There's some. I'm not really dumb at counting. It's just there's some things that I can't see some other guys. But yeah, it looks pretty good. So what about Python? Raise your hands if Python. Holy cows, man! 1, 2, 3. I don't know, man. It's pretty close. Somebody want to count for me?
Can we just split it down the middle and take those things together?
Somebody has 2 hands up. Don't put this. Just 1 hand, okay? Just 1 hand up, no 2 hands. All right. What do you think, Scott?
That's hard.
Okay, raise your hand for R. Put it up high.
11, 12, 13, 14, 15.
Which program can count votes better?
Remember, there's an awesome certificate coming to these guys. Forget about the Amazon gift. There's like a awesome certificate.
I can't go back to work with a mediocre.
What about Python?
Python.
All right. Put your foot down somewhere. No foot's counting. What do you think? What is it?
It's 15 or so.
15 or so? Versus. 1 more hour? 1 more hour? No, unfortunately, there can't be a tie because there's like that certificate is, the first one is so awesome.
I gracefully concede.
We could do wrestling if you
No, we don't need to do this.
Okay. Well, I think we're gonna, if you concede,
That's fine.
if you're cool, then I think R1.
All right.
And as promised, you will get your outstanding, I'll put your name on there.
Okay, yeah, we got right in.
Outstanding achievement for, outstanding achievement in excellence.
Yeah.
Did I spell it right? Make sure that I.
You did.
Oh, man.
Yeah.
Awesome.
Yeah, that's good.
Good enough. Good enough. All right. Awesome. And second place.
All right.
Oh, we got a comment, please.
Okay. Let me just TRAEY.
Yeah. There you go.
U.
EY.
Okay. AU.
Close. That's fine.
Awesome. All right. Mediocre
sir.
achievement.
All right.
All right. Give these guys again, please. That's awesome. Great. You guys want to say a few words, or you want to hit the bar?
Sure. I will say. So I will say I'm participating here because we are currently hiring at Enowatts. If any of you guys are interested in solving problems with Python or R every day, data engineering, data science. Our platform team, which is like our web UI team, we're actively looking for people in junior roles, senior roles, all across the board. So if you're interested, please come talk to me. I'd love to talk to you about it.
And I'm here to promote the City of Houston Hackathon that's coming up in May. It's an annual event. We get a bunch of people from the community together with stakeholders and nonprofits and city government. They come to you with data problems usually. Some of them are pretty far along and then they need just a little bit of help here, or some of them just need help figuring out what to do with the data that they have. And it's a great opportunity to practice your skills and make a difference. So please look out for that. I'm gonna send the link to Francisco. Maybe we can cross-post it on HEDS or something. And leading up to that, we're gonna have some free intro to R, intro to Python type of workshops. So if you want to cut your teeth on one or the other, come and check those out too.
When is the date? What time?
I think it's May 17th and 18th, but I'm going to send a link to him and he'll get it posted. I'll confirm that.
Okay, thank you. And a few comments from me. We have our next meetup coming up in Ranch Office, which is a new co-work space over by Spring Branch. So it's the Data Stacks. is going to have a data scientist from Pioneer and another gentleman who I don't know where he's from, but we're going to have that coming up in a couple of weeks. Also, I want to thank you guys, and I want to thank Flatiron for hosting this event, and I want to thank Enaxis. And one more thing, I'm not getting paid enough right now in my job, so please subscribe to the channel so I can become a YouTube star and try and make extra money. I have 2 kids, they're young, and I want to put them through school, so please subscribe to this channel. I'll send you the link. Yeah, I want the YouTube money and some ads, so please do that for me. It'll be a big favor. So thank you very much, and thank you for coming, and we'll see you next time.
Yeah, it's great talk.